Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, helping you learn everywhere you go. I'm Zach Memis, your host, as we continue on with CompTIA Net Plus Classless IPv4 Addressing Part 2. And Wes Bryant is here to help us out. Wes, great to see you, sir.
Hey, thanks for having me back, Zach. That's right. We got to continue down this path that leads to classless systems. That's right. In the first part here, we were kind of talking about, one of the reasons we would use classless systems, and it really just boils down to the inevitable depletion of that 32-bit IPv4 address space. Keeping in mind that really all we can address, the only addresses that are available are in A, B, and C. Remember, we didn't even mention here that the fact that D is all for multicast. We've mentioned it in other episodes, but D is all for multicast, and E was never given to the public anyways. That was basically held for research and scientific purposes only, right? Military purposes, if you will. But it was never given out to the public, so we really only have A, B, and C to deal with. And the problem is the classful system, like we said in the first part, very wasteful. Now, one of the last things that we mentioned is we started to look at some of the subnet masks that you could see in a classful addressing system, and we started talking about the decimal values. If we could go to my screen here, remember this is where we left off. We talked about, hey, I could manipulate these bits. I could borrow bits from the host if I wanted to, and I have to make sure that the subnet mask still has that same contiguous 1 bits from the left to the right, and that's why I told you that you could see additional numbers like this, but you have to understand the binary, right? So we also looked at this chart because these are the 8 values that from the left side, let's try that again there, these are the 8 values from that side that are really responsible or are the valid ranges. And again, 128, 192, 224, 240, 248, 252, 254, 255. Now, if you can memorize these and also memorize how many bits they are, you're going to be doing great for the exam. But I also want to introduce something else that they call out on the exam objectives, and that's something known as CIDR notation. Because I want you to look at, when we denote something like this and we just say 255.255.255.248, right? That's a pretty big number to always be writing out, right? And as admins, we try to script everything out. Anytime we can automate the process, what we want to do is we want to reduce the amount of administrative effort. So we got to kind of look at something like, known as CIDR notation.
So I suppose we're not talking about something made out of apples, right?
Yeah, it's spelled a little bit different, but it's pronounced the same, right?
Okay.
When we say CIDR, again, we're talking about CIDR, and it's how your internet service providers perform what's known as classless interdomain routing, and it has a way that it's written out. And it really, if you start to write down IP address or networks with their subnet mask ranges, if you will, in CIDR notation, becomes easy. It's kind of like a little shorthand, if you will. But how do we do that? All right. Well, I want you to look at the. We'll start with the default subnet masks that we've already been looking at here, and I want you to look at how many 1 bits, right? If we talk about 255.0.0.0, how many 1 bits are in that subnet mask? Well, we've already talked about this before. Remember, that's 1 octet. Where those 255s are, that's 1 octet that is full of 1 bits. So, what is a full octet of 1 bits? How many 1 bits? 8, right? So rather than say 255.0.0.0, what we could do is we could change this and we could do a /8. We do a /8. Now what we're saying is the same thing, 255.0.0.0, but we're writing it with CIDR notation. And in CIDR notation, all we're doing is just representing the amount of 1 bits that are in the subnet mask rather than writing out the entire decimal value there.
I like it.
Right? So if we go a little bit farther than that, right, and we look at, well, what, our classful B address or B default subnet mask, right? Well, how many 1 bits are inside of our class B default subnet mask? Well, now I have 2 octets of 1 bits, right? So 8 plus 8 is what? 16. So rather than say 255.255.255, or excuse me, 255.255.0.0, I can just do a /16, right? And /16 tells me right away that it's the same thing as 255.255.0.0, but instead I'm doing it shorthand and I'm saying 16 1 bits in the subnet mask right away. All right, now let's do, and for completion, let me change this back to a classful subnet mask. Let's do that same thing, CIDR notation, if we were for our Class B, Class C default subnet mask. Thank you there, Zach. And we do the same thing. Well, now, what do we have? We've got 3 octets of 1 bits. 255.255.255.0. That's 8 plus 8 plus 8, or 8 times 3 is 24.
/24.
Right? So this is going to be a /24. Now, I could, if I was writing down, and we'll get to this part here, I could say, okay, your network ID is 192.168.0.0, and you have a subnet mask of 255.255.255.0. Or I could just write it out this way. I could say /24. And what we're saying is pretty much one and the same. And it's easier. It's a shorthand. It's just saying how many bits are in the subnet mask. Now here's where this starts to come into, starts to get confusing for people who maybe have seen it for the first time. There's a reason I started with the classful subnet masks first. Because you might say, well, Wes, we don't follow the class system anymore, the classful system, but yet you're still saying Class A, Class B, Class C, Class A default, Class C or B default. Well, that's because we still use them as way markers, right? I still say, hey, Zach, I got a Class B address, right? Well, if Zach knows what the B range is, he knows where that would fall, right? That would be between that 128 and that 191, right? In that first octet. So you would know. So we still use them as way markers. And I want you to use, for your CIDR notations, I want you to use your classful system as a way marker. Right? And here's why I say that. Because if we take something like, I don't know, maybe something like this right here, and we decide, hey, I want to go ahead and I'm gonna steer away from the classful system, and they tell you, all right, I need a /9. Well, do you know how to figure out what the decimal value of a /9 is? If I know a /8, right, it's 255.0.0.0, would you be able on the exam to get this right if they asked you, what is a /9? All right, now we're classless, right? We're breaking the barriers, right? Well, this is where this chart that I was showing you comes in handy, all right? If I have a /9, well, I know that I have 8 bits, so that means 1 octet has to be 255, right? That's my way marker. So what's the decimal value for 1 extra bit? Well, it's 128. So I can see that a /9 would have to be 255.255.128, or excuse me, 255.128.0.0, right? Because I'm using that class A default subnet mask as my way marker. I know /8 has got to be 255. Well, what would be 1 bit after that, right? If I borrowed that bit, well, we've already kind of seen that. If I take and I add that 1 bit over here, and I turn that on and turn that into an additional bit, well, now I have those 9 bits, right? There's my /9. Well, remember what we said in the first part, that second octet, well, what is this 8-bit value? Well, that's where this chart that I'm showing you comes in handy. I know that that's a 128. All right, so I know that a /9 is a 255, because I already got 8 bits, plus that 1 bit. Well, what's 1 bit extra? That's 128. And you can do this very easy, right? If it happened to be a /, let's just say randomly, I say /12. All right, well, if it's a /12, I know that I have at least 8 bits, right? So I know that I got 255. I've started there. That's why I colored these green here, too, to kind of give you something that you can look at, right? I know that 255 is going to be there, right? I already have 8 bits. But how many extra bits do I have than 8? Well, that's easy enough. 12 minus 8 is what? 4. So now I have to figure out what 4 bits are. Well, if you can remember the chart, 4 bits, that's 240, right? I can remember 128, 192, 224, 240. I remember 4 bits. And I can come to those answers really quick, and I know that a /12, right, has to be a 255, because I got those 8 bits,
Right.
.240, right? And those are my 4 bits. And that would be no different here if we were turning on those extra 4 bits in this octet right here, and we make them 1s. So that is CIDR notation, and it's important to understand that they very well might ask you to do something like this on the exam, all right? So what we're doing is we're kind of getting around some of the jargon, you know, that you might see as it leads us into, you know, more complex topics, again, if you're seeing it for the first time. Well, let's not stop there, right? Let's go ahead and say, well, and let me change this back to classful, right? So now we got back to our 255.0.0.0. All right, well, what if they tell me I've got a /20? Well, I know 20 isn't as great as 24, right? So I know that I'm not within that range. So I still have my 2 octets that are 16 bits, right? Well, what is 20 minus 16? It's going to be 4, right? Well, I think we just did 4 bits. What is that third octet going to be with 4 bits? Well, didn't we just do that? We just looked at our chart, right? Mm-hmm. And what was our chart for 4 bits up here? Up here, right here? Well, it's going to be the same thing, right? If I go back to my chart, we're still dealing with 8 bits, and 4 bits is going to be 240. So I kind of threw you a curveball there, right?
Yeah, a little bit.
All right. So that just means that that's going to be 255.255.240. All I did was shift it over to 240 on you guys. Sorry, that was cruel of me, right? But you can see how I'm using those classful CIDR notations as my way markers, right? Well, what if they give you, I don't know, let's do another one here. What if they give you /19? All right, well, that means that I know that I still have my /16, right? I know that that is my way marker. So what is 19 minus 16? What does that give me left? It gives me 3 bits. Well, that's okay. That means I'm going to come over here in this last octet, and what we're going to do, because we know we have the first 2 octets of 255s, then what I'm going to do is I'm going to add these 3 bits here. And what are 3 bits? Well, go back to your chart, right? 224, right? 1, 2, 3. That is that 8-bit increment, right? So I know that a /19 is going to be, my 255s are there. Remember, my class B is my way marker. I already got 16 bits. So I know that that's going to be, and again, remember, 224. Make sure, just double check that I marked that right. All right, so that's going to be 224. All right, so there's your /19. And you can do this. We can even give you some examples. Let me go ahead and change these back to classful again. We can even give you some examples. Oops. I'll try that one more time. We can even give you some examples in the Class C range if they do this. And I'm going to come to completion on why we're doing this, because you might just see CIDR notation, and they might give you basic questions like this in order to understand, to prove that you understand the concept. Well, what if I have a I don't know, I was going to say 28, but that would be 4 bits again. Let's try this one. How about a /29, right? Mm-hmm. Well, I know 24 has got to be at, somewhere around here. 24 bits have to be there, right? So that's 255.255.255. Now I just take 29 and I subtract 24. What does that give me a remainder of? It gives me a remainder of 5. Now I know I'm dealing with 5 bits left, right? So if we come back to this last octet and we ensure that there are 5 bits, again, turned on, right? And I've got 1, so there's my 5 bits. Well, now I'm not even going to my chart, because I want you to be able to do 128, 192, 224, 240, 248, right? I know that this, with a slash with 5 bits there, this has got to be a 248. And just until you get it memorized, if you want to check, are 5 bits a 248, awesome. Right? So you can start to see how they come up with these numbers, right? You have to be able to tell if they give you a CIDR notation and they say, what's the subnet mask for this CIDR notation? Or it might be the other way. They might give you something like this where they say, what's the CIDR notation for this subnet mask? All right, well, let's make it easy. I know I've got 24 1 bits right here, right? 255.255.255. Mm-hmm. 8 plus 8 plus 8. Mm-hmm. Now I just have to figure out what's a 248. All right. Well, that's easy enough. You could subtract 255 and you can kind of figure out, but the easiest way to do it is, again, just counting those bits. If I know I have 8 bits, I got a 128, 192, 224, 240, 248. I've got 5 bits, so I've got 24 plus 5, and that gives me my /29. Mm-hmm. So again, you're kind of seeing both ways that you can kind of figure out how to do the CIDR notation, right? And that's going to be important. All right, so let's go ahead and let's move into a concept, and we'll probably do a few of these, because this is one that starts to get a little bit tricky. This is one of those ones where people are like, I understand. No, I don't. I lost it. And I'm going to tell you what, I did that many, many times, and I have to go back and I have to brush the dust off of this as well. But I want you to think about it when it comes to something known as subnetting. All right? Subnetting is essentially nothing more than taking one large network and dividing it up into smaller networks. Now, there's a couple different reasons that we can do this, right? One of the reasons that we can do this is to divide up broadcast domains, right? Because when you have a router that's connected to two different subnets, they do not pass broadcast traffic between the subnet mask, or at least not by default, right? So what does that do? Well, it can eliminate broadcast, the amount of broadcast traffic that's on your networks, right? If you've got a couple of servers, like maybe you got 10 servers within your networks, and they're all talking to each other, sending broadcast communications, and they don't need to send communications to anybody else, why don't I just put them on their own subnet, and they can just yell at each other all they want, and they're not going to impede the traffic that is on another subnet, because again, that router isn't going to pass that traffic. The other reason we'll do something like subnetting again is to make sure that we have less waste of our IP addresses. Let me show you what I mean here. So very basically, if we look at, and I'm going to use a private IP address range, right? We've got a network right here, right? And this is our network ID, and we're going to get into in the binary how I can tell that, what a network ID is, and we'll talk about another address that's reserved, okay? So our network is the 192.168.0.0 network, and let me go ahead and change that. Sorry about that, guys. There we go. And we're just going with a classful system, all right? Well, I want you to think of how many bits I have in the host portion. Remember the 0 bits of the host portion, right? Mm-hmm. If I have 8 bits, that's 2 to the power of 8, all right? Well, technically, that gives me 255 because 0 counts, but the very first address in a network is reserved. That's the network ID, all right? And you can't give that to anybody. So I can't use that. That's 1 right off the top. So even though technically you would say, well, actually, 2 to the power of 8 is 256. Let me be clear about that, right? So I can't give the very first possibility, if you will, within that range, because that very first possibility is the network ID. And remember, we told you the rules of IP addressing is that every computer has to share the same network ID, kind of like the street name. Street name has to be the same if all the houses are going to be considered to be on the same street, right? They have to share the same street name. Just the same thing with networking. If a computer is going to be considered to be on the same network, all those computers have to share that network ID. So unfortunately, we lose that possibility right off the top. So now I'm down to 255. I went from 256 to 255. Okay. Now I'll tell you the last address within a range, network range, and in this case, and I'll show you why in the bits here coming up, cannot be allocated to anybody at all either. Why? Well, the last address within the range is what's known as the broadcast address. When you need to send a broadcast communication over layer 3, to that subnet, everybody on that subnet, like I said, those servers that are shouting to everybody, right? You have to have a special address that you send that communication to, and you send it to the broadcast address. That address everybody uses as well. So now we're down 2 addresses. We can't use the network ID. That's the very first possibility within your network range. In this case, it's 192.168.0.0. The very last address within the range is what's known as the broadcast address, and all computers share that because that's how they send broadcast communication. So now we're down 2. Now you can see why I told you that when we were talking about the classful system and we mentioned that with 8 bits, right, only 8 bits reserved for the host, I get 254 nodes on that network. Why? Because technically 2 to the power of 8 is 256, but I cannot use the network ID and I can't use the broadcast, all right? Now, that being said, that's how I'm getting 254. And like I said, I'll show you guys and gals out there how exactly we identify that coming up, all right? So why would I want a subnet again? Well, maybe I don't want 254 computers on the same broadcast domain, right? Because that means every time somebody sends a broadcast, who hears a broadcast? Do you remember we said that was a 1 to what? That was a one to everybody, right? And in some of our other shows that Zach and I were together, I said that's like jumping up in the food court and screaming at your lungs, right?
And that's an easy one to remember, too. It's broadcasts to everybody.
That's exactly it. Everybody hears it. Well, again, that's a lot of chatter. And there is no reason for me to shout to where everybody back here in the studios hears it if all I need to do is talk to Zach. we could just keep the communications within this studio, right? So what we do is, again, we're going to isolate some of those broadcast communications, right? And we can do that through subnetting. The other thing that we can do too is we can also better utilize the amount of IP addresses that we have, all right? So let's go ahead and let's dive into, it looks like we're gonna run a little bit short on time here, so let's go ahead and kind of dive into what I want you to know as octet isolation. All right, and what I mean by that is when we subnet, we have to determine what are the host bits that we have to work with, right? That's how you subnet. If you're gonna increase the amount of networks, you only have 32 bits to work with, right? So if I increase the networks, what do I have to do to increase networks? I have to increase the amount of network bits that I have. And in doing that, what am I taking from? The host bits, right? So when you subnet, what you're doing, and that's why I said borrowing bits, you're borrowing bits from the host, all right? And that's why it's important. See, maybe up to this point, especially with the Classless system, you might have said, well, Wes, why are we going through the process of binary conversion? I can look at a 255.255.255.0 and I can see where the network bits start and stop. Well, you can always see where they start. They start from the left. You can see where they stop and where the host bits start, all right? But what if I give you a 255.255.255.224? Could you, in the decimal, from the very first start, could you tell where the dividing line is between the network and node portion? And it's not quite that easy. And that's why you need to see these underlying bits. And that's why we go through the process of showing you the decimal to binary conversion. It's important, all right?
Right.
So in order to do this, let's understand that when you apply a subnet mask, all right, or you're going to subnet, you're always going to have a starting point, right? And let's say, for instance, let's say that your starting point is this right here. And I'm going to use, and let me show you this example. So I'm going to use both the CIDR notation at this point and just the regular decimal subnet mask notation, just so we can kind of see what's going on. And if this is the first time you've seen it, maybe it's all new to you, all right? Well, if you look at this subnet mask, what octet are my host bits? What octet do I have to work with? Because to add networks, I have to borrow from the host or the node bits, right? The host bits. Well, that's that last octet, right? We said when it comes to the node portion of an address, that's where all the zeros are. So I don't have to worry about anything in the 255 range at all. Why don't I have to worry about anything in the 255 range? I know they're already part of the network. I need to make another network. So these network bits are already included, so I can just forget them. What I need to focus on is this octet right here. All right, so what do? Well, we're going to take that octet and we're going to start it out as though it was host bits. All right, and yes, we're going to put it in the binary. All right, maybe. There we go. And let me do a little formatting here and make this a little easier to see.
Very nice.
All right, there we go. All right, so we have this octet is what we're working with, right? This last octet. Now, that means I also am going to work with that portion of the IP address that's also a part of the host bits, right? Which would be that last octet as well. So we'll go ahead, and I already know that that last octet, since it's zeros, we got zeros over zeros, right? All right, so what we're going to do is we'll go ahead and we'll put these zeros up here as well. And we will move forward. All right, so I got my 0, 0, 0, 0, 0, 0, 0, right? So this is the octet. Keep in mind, last octet in the IP address. This right here is the last octet in the subnet mask. All right. So if I want to start adding networks, I have to add network bits. All right. Now, when you do that, you're basically borrowing a bit from the host. So I'm going to take this bit and I'm going to turn it on, and if you remember, that turns that portion of this address into the network portion. Follow the color coding? Since we just turned that bit on in that last octet of the subnet mask, we borrowed that bit from the node, it now becomes, in the IP address, a portion of the network bits, right? Well, when you borrow 1 bit, how many possibilities does that give you? Well, I want you to think about how we came up with our place values. Remember I said when you come up with your place values, that's 2 to the power of 0 equals 1, 2 to the power of 2, well, or 2 to the power of 1, excuse me. Let me get that right again. 2 to the power of 0 is 2 times itself, right? 2 to the power of 1 is 2 times, wait a second. I'm sorry, I'm getting this wrong. Try that again. 2 to the power of 0 is 1. Anything to the power of 0 is 1, and that's where I was getting lost here. 2 to the power of 1 is 2 times itself, which is 2. 2 to the power of 2 is 2 times 2 is 4. So you see how we're getting these. These are exponential values.
Yes.
Well, if I borrow 1 bit, that essentially is 2 to the power of 1. All right? So if I have 2 to the power of 1, what do I have? I've got 2 times 1, right? 2 times 1 is what? That's basically going to be a 2. Mm-hmm. So that tells me that I have 2 possible networks that I've just created. Let me show you what I mean. You always start with the very first, all right, possible, the 0, all right? So the 0 address is the very first network that we have. But when I turn this bit on and I make this part of the network, well, what can those 2 possible values be? Well, those values can be a 0 or they can be a binary 1, right? Mm-hmm. And these 2 possible values, since they're part of the network bits, they actually join up our network ID. They make our network ID. All right, because the first address within any, remember I told you the first possibility within any network essentially becomes your network IDs.
Right.
Well, my 2 possibilities here are either a binary 0 or a binary 1. Well, guess what? We're going to move the dividing line in our network, and we're going to put it basically right here, all right? Where before in our classful system, notice that we had these clearly defined walls, right, mm-hmm. in between each octet. Mm-hmm. Well, essentially, that is like taking this whole entire line, and what we're going to do is we're essentially going to move it one place, right? We're going to move it from here to this side. All right, so let's go ahead and let's do that. Let me see how I can do that real quick. Let me just go ahead and insert. Let's see if, oh, that's not what I wanted. Let's try that again one more time. So we're going to insert a line here, and I want you to think of our dividing line now within our network, between our network portion and our host portion, as now being right here. Oh, that did not work. Let's try that one more time. There we go. All right. So these are the 2 possibilities that if we borrow 1 bit, I get 2 to the power of 1. That's that 1 bit that I borrowed. And 2 to the power of 1 exponentially is 2, right? Well, how does that literally make those 2 combinations? Well, now that these are network bits, my 2 possibilities are 0 or 1. That means that every one of these bits behind here are all host bits, right? Or all node bits. Well, look here. The very first address within a network is called the network ID, and it's defined by all, now follow me on this one, the network identifiers within a network are defined as being all zeros in the host portion. That's how we tell the network IDs. That's mm-hmm. how you identify that as being the network ID that every node will share. So if I take and I go 0, 0, 0, 0, 0, 0, all in the host bits, right? Follow me there. Mm-hmm. All in the host bits. Mm-hmm. These 2, and let me center these up a little bit. That means this value right here taken out of binary becomes our very first network that we've just created. And in this case, it's 192.168. Oops, 192.168. Thank you, autofill. .0.0. And I know that doesn't seem like it changed anything, because it really didn't, because you still have that very first base address. But now what you'll see is I also have a second network. Remember, I've got 2 possibilities here mm-hmm. for this bit position. Mm-hmm. All zeros in the host portion mm-hmm. makes this 8-bit value our next network, our next network ID that we just created. So that is going to be, and let me change this around here. Probably should have done this before the show, but that's okay. We'll do it on the fly. That always works, right? We're going to do 192.168.1 or .0. And you have to figure out what is 1 followed by all zeros from binary to decimal. Well, it's 128. All right, so the two networks that we just created here by borrowing a bit from the host created us two networks, all right? Two networks, and these are what are known as the net IDs. 192.168.0.0, and we could do a /25, right? Because we've now got an extra bit. We borrowed a bit. No more 25 or 24. Now we've got 25 bits.
Right.
So when you choose to make a /25 on these, you've essentially subnetted a large 254 node network into two 126 node networks. Now, technically, the possibilities, keep in mind, are 128. But I cannot use this very first possibility as an IP address for the host because it's the network ID, right? I cannot use this second network here, the very first possibility, as a host IP address because it's also a network ID. Well, how do we figure out the broadcast within these network ranges? All right. Well, that is defined as being all 1 bits in the host portion or node portion. So take the dividing line and just past that dividing line where you know these are node bits and put all 1s in there and then take that out of the binary. So if the network IDs for this network here, or the network ID for this is 192.168.0.0, what is the broadcast ID? Well, the broadcast, or address as it's called, the broadcast address is going to be that number that is all 1s in the host portion. Well, what is this number, if you will, taken out of the binary and put into decimal? Well, it is 192.168.0.127. So that becomes the broadcast ID. So now we have what's known as the network ID. I can't give the network ID out, right? The network ID is defined as all zeros in the host portion. Take that same network, same thing, but turn the host portion into all 1s, and it tells me what the broadcast address is. All right, and if I pull that out of the binary back into the decimal, I can see that the broadcast address for this network is 192.168.0.127. Well, remember the second network, I told you the two possibilities was a 0 or a 1. That's part of the network. So all zeros in the host portion or node portion becomes our network ID, and that would be 128, right? A 1 followed by all zeros. But if I turn this into all 1s in the node portion, that now gives me what the broadcast ID is, or the broadcast address is for that network. Well, that tells me that the broadcast ID, or address, if you will, is going to be what? Well, what's all 1s in an octet? It's going to be 192.168.0.255. All right? So what we end up having here is we have our network IDs on one side, right? These are our network IDs. And on this side, what we end up having is what is known as our broadcast address, right? So we can say our broadcast address, all right? And you have to know that, right? When you start with this process of subnetting, I have to know what is the network ID. If they give you an IP address with this slash notation, they give you something like 192.168.0.128/125, they say, is this a valid IP address within that network? Well, you would have to know by doing the binary here, but no, that cannot be a valid IP address, because if I put it in the binary and I do the division here, basically drawing that line between the network portion and the node portion, I notice that there are all zeros in the node portion. That can't be an IP address. That has to be a network ID, right? Just like looking at 127, if I look at 192.168.0.127 and it has a /25 on it, and they say, is this a valid IP address for that network range? Well, no. Because if I look, 127, after I've done my subnetting, is all 1s in the host bit. That means it has to be the broadcast address. I cannot allocate that to a computer. So what we know now is that in between these ranges are where our IP addresses stand. And what that means for me is that within this network here, what I'm going to end up having is an addressable range, and we'll just look at that last octet, right? Looking at that last octet, that I know that I can't use the first address, so I can use .1 through, can't use the 127, that's the broadcast address, right? So I can use .1 to .126, and for this network, I can use what? I can use, well, I can't use the 128, right? The 128 is going to be our network ID, so that means I can use .129, right? That's the first valid IP address. I can't use 255, right, because 255 is the broadcast address, so I have to use .254. All right, so that essentially is where we're getting the 126 computers. So the question would be, if I do this, what is actually happening? All right, well, let's go ahead and I know we're well out of time here. We'll come back in a part 3, but what I've done with this is I've essentially said, okay, I've created 2 networks now. Right? So now we've got two subnets, right? Because we're subnetting here. And network A is, this is the network ID. So network A here. All right. And network B, or subnet B, if you will, is, well, what? It is, remember what we said, 192.168.0.128? I've essentially created 2 subnets. We've got subnet, or network A, and network B, and now we have 2 broadcast domains as well, all right? And essentially I can now put 126 computers on this network, and I can put 126 networks or computers on this network B as well. And then I also, inside of each of those networks, if I'm only using, let's say, 50 computers, well, I still have 50-something extra addresses, 60-something extra addresses that I can use for future growth. Now, that's only one example. We got some more examples that we want to show you. Maybe we want to go even farther, right? Maybe we want to make 4 networks. We want to put 4 networks, and we want to have 50 computers on each network. Or maybe we want 3 networks, right? And we want to have an extra network just left over for future growth. Well, we're going to show you how to do that, but we don't have time to do it in this episode.
Classless IPv4 addressing part 3 coming your way. This has been part 2. There is a part 1. I tell you what, it's valuable information. If I were you, I'd be watching all 3 of them many times. And in fact, see everything that was put together for you in the CompTIA Net Plus series. And inside that course library, there's hundreds of other videos, all designed to help you go further. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. I'm Zach Memis.
And I'm Wes Bryan.
And we'll see you soon.
Thank you for watching IT Pro TV.